objective 5 is about solving linear absolute value equations. So absolute value is represented by these vertical bars outside of the expression. And the only thing you need to remember is to start solving an absolute value equation, we will split that equation into two separate linear equations without the absolute value sign. Remember that the absolute value turns everything that's in it into a non-negative number, right? It will remove the negative sign for you. Like that's what the function does. So if absolute value of x equals to 5, you have to remember that x could be 5, but x could also be negative 5.
Professor Yan,
yeah.
I've heard like absolute value is like the distance from 0, whether negative or positive. So -5 is 5 away from 0, and +5 is 5 away from 0. So the absolute value of 5 or -5 is the same. It's they're the same distance from 0. Is that absolute value?
Yeah, that is cool. Yeah, that is the one definition. Yes. So it will return the distance to 0. So if you are negative, but it just means like on the number line, right? You're to the left of 0, but the distance is always either 0 or positive. So if you are never going to do physics or engineering, I don't think there's much use for absolute value. But for engineers and physicists, they do start having absolute value, like Professor Blair said, it is the distance to the origin, to the 0. So when people start using vectors and direction stuff, then you start having absolute value. So for example, in real life, I can think of an application right now, which is like velocity. Your car is always running, right? But if you are going in the different direction, opposite direction from mine, your velocity is considered negative velocity, right? Because we put a line and it's like whoever is going on the, like, let's say if you're going on the right way of the street, your velocity is positive, but if you're going against traffic, then your velocity is negative. But the true velocity is your absolute value, right? Because you have a speed. So in real life, like what we call like speed is the absolute value of velocity, for example. So you do actually end up, the negative actually is it's a symbol of direction, right? The direction that everybody goes, or the defined direction, is a positive one. If you're against the defined direction, it's kind of like the negative. But then absolute value is your actual inherent value, let's say, your size or the speed. I don't know if that made it worse, or did that answer that? No, but like the absolute value itself can be generalized. Like it will be used like this function can be used in more than one dimension, and then it will mean the actual size or length of a vector. So people will use that like later. Okay, so then I have an example of I wrote like a simpler example of how to solve a linear absolute value equation. So we have negative x plus 9. So it's negative x plus 9 equals 25. So what I'm saying is, let's remove the absolute value. To remove the absolute value, it becomes two things that we need to solve. Whatever it's inside, either whatever it's inside the way it is equal to 25, or the negative of this. So I'll put a little negative here. Negative of this is equal to 25. Or actually, sorry, maybe this is not, I messed it up. Wait, Control. This is maybe easier. Or this is equal to, the thing that was inside the absolute value was actually equal to negative 25, right? Maybe this is prettier, like this. It's the same, actually. Yeah? Since the absolute value equals to 25, what was inside the absolute value was either equal to 25 or equal to negative 25, right? And then you separately solve these things. It basically becomes two problems. So if negative x plus 9 equals, negative x plus 9 equals to 25, then negative x equals to 25 plus minus 9, right? Negative x equals to 16. So here you multiply everybody by minus 1. Is that okay? So minus 1 everyone. Multiplication. So you get x equals to negative 16. So that's one solution. Okay. And then here you are going to have another solution, which is negative x equals to negative 25 minus 9. So negative x equals to negative 34 maybe. And then multiply everybody by minus 1. You have x equal to 34. So you usually have two answers, yeah? It's normal. You have x equals to negative 16 is an answer, x equal to 34 is an answer. Amanda has a question.
So I did this as you were doing it, but I changed, I got the same answers, but I'm wondering if there's a problem because I made my equations instead of to negative 25, I did negative x plus 9 equals 25, and then I did x minus 9. So I just changed the signs within the absolute value instead of changing the sign on the answer. And I got the same answer as you did, but is there a time when that would not work?
No,
or is that
it always works. That was what I was writing before, but I thought that would be more complicated. It's the same because instead of starting with this equation, instead of doing that, you multiply this by minus 1. So then it becomes minus, you did this, you started with the same equation actually, just
okay. That's what I thought. I just
that was the one I was going to, but I thought that was, you did a more complicated version, I think, because why I say more complicated, because we sometimes forget there's like minus with minus, multiplication becomes a plus, we drop one minus, and then everything gets messed up. Like the negative signs are a pain. So make sure you don't forget your negative. And it makes sense because like Professor mentioned, absolute value means a distance. So when you have an absolute value equation, basically all the questions are asking like, what are the points that are 25 units from this other point, right? So you will actually have 25 units to the left and 25 units to the right. So you usually have two solutions anyway. They are equidistant from some other point.